into content. So today I'm going to teach you about imaginary numbers. And I know you have never heard of that before. So let's talk about why we need them. So in geometry, you talked about parabolas, how they could cross over the x-axis twice with two solutions or one time with one solution. Then we talked about how sometimes they don't cross over the x-axis and then they don't have any real solutions. That is why we need imaginary numbers. Also, solutions means the same thing as roots and x-intercepts. So before we dive into all things let's kind of back up for a second and remember how we simplify radicals in the first place. Because remember, when we have parabolas, we've got squares. In order to undo squares, we have to square root. So we're going to start with simplifying normal square roots from geometry or even potentially algebra 1. So number 1, I'm going to take the square root of 50. I like to factor tree. So I'm going to think of two numbers that multiply together to give me 50, 25, and 2. 2 is prime, so I underline it. 25 can multiply with 5 and 5. Since I multiplied 25, I'm going to cross it out. I've got a pair, I call those dates. Dates, they go out of the radical. The 2 stays behind. So when I simplify this, I have 5 root 2. So number 2, now let's take a look at the square root of 45. Two numbers that multiply together to give me 45, 3 and 15. 3 is prime, so I underline it. Two numbers that multiply together to give me 15, 3 and 5. So since I multiplied 15, I'm going to cross it out. 3 and 5 are prime, so I underline them. I have a pair of 3s. They are my date. Dates go out. The 5 has to stay back. Notice that I didn't use the 15 because I crossed it out. All right, so now let's up our game a little bit. This time I'm going to put a number on the outside. So we're going to have 3 root 28. When you start this problem, just think about the 28. So two numbers that multiply together to give me 28. Let's do 4 and 7. So 7 is prime, so I'm going to underline it. 4 multiplies with 2 and 2. Since I multiplied it, I'm going to cross it out. 2s are prime, so they are my dates. But here's where you have to be careful. 3 is also on the outside, so it's understood to be a date. Multiply your dates together. We've got 6 root 7. Let's try one more. So number 4, this time we're going to have the square root of 36 divided by 25. Now, I know that you guys are looking at this right now and you are having a minor heart attack. Do not panic. One of my goals this year is to teach you how to manipulate fractions so they become less scary. So for this problem, I want you to separate them. The square root of 36 over the square root of 25. Now, I see 36 and 25 and immediately know perfect squares. So that's going to give me 6 and 5. If you need to factor tree them, go for it. Now, this is where I comes in. I is the square root of -1. Until now, your math teachers probably told you that you can't or you don't know how yet to find the square root of a negative number. That's going to change today. So I works kind of like a variable. It just has a set value. It can never change. I is always the square root of -1. So now let's see how we are going to apply that in a problem. It's going to look similar to the ones that you just did. So let's start off fairly simple. So we're going to start with the square root of -2. What I want you to do is split them apart. So let's look at the -1 and just the 2. So the square root of -1 by definition is I. And that's all we're going to do is just write I underneath it. 2 is already prime, so we're just going to attach it. So our answer is just I root 2. And I understand that that probably looks weird, and it will for a while. But the more you do this, the more it's going to just come naturally. So let's up our level. Square root of -4. Same idea, separate them. Let's look at the square root of -1 and the square root of 4. The square root of -1 is I, so I'm just going to drop that underneath. Now let's factor tree the 4. I've got 2 and 2, which are dates. Nothing is left behind, so I just have 2. But watch how this answer looks. It's 2I. So integers go before the I. Radicals or square roots go after the I. All right, now number 3. Let's level up right again. So this time we are going to have 3. Oops, sorry, I got ahead of myself. Square root of -12. Okay, attack it the exact same process. So take the -1 out. So I have the square root of -1 times 12. Two numbers that multiply together to give me 12, 4 and 3. 3 is prime, 4 is not. Two numbers that multiply to give me 4, 2 and 2. That is my date. and I'm going to remember that I have an I. Notice how I did this backwards this time. That's okay. So I'm going to have 2I root 3. Remember, integers go before the I, square roots go after the I. So if you have both, the I goes in the middle. All right, let's level up again. I'm going to zoom out a little bit so you can use numbers 1, 2, and 3 to help you as we go through number 4. So number 4, this one is going to be my 3 square root negative 16. Okay, so separate them. So I'm going to have 3 times the square root of negative 1 times the square root of 16. So I know that the square root of negative 1 is I, so I'm going to drop that down. And now I need to factor tree 16. 16 is 4 and 4, and I already see those pairs, so I'm going to say, okay, I know that's a pair. But I'm going to remember that I have the 3 on the outside, which is also a date. So I multiply 3 and 4 together, which gave me the 12. And since 12 is an integer, the I goes behind it. So we've got 12I. All right, let's do a couple more before I set you loose, okay? So number 5, this time we're gonna have the square root of negative 75. So I did a double negative here on purpose. So that negative up front is just negative 1. Then I've got times the square root of negative 1 and 75. So 75 breaks down, I'm gonna say, let's do 25 and 3. 3 is prime, so I'm going to underline it. 25 multiplies by 5 and 5. Since I multiplied 25, I'm going to cross it out. 5s are prime, and they're my dates. So I also have the date that's already on the outside, which is my negative 1. So it's actually going to become negative 5I root 3. Notice how I gave myself lots of space to think. While you're getting used to these problems, I highly suggest that you don't try to squish them up all together because everything can get muddled up if you do not give yourself adequate space. All right, number 6, and this one will be the last one. So I've got 8 plus the square root of negative 8. Now this is the first time you've seen a plus sign being thrown into the mix. So this part, this 8 plus, I just want you to leave it alone for a little while and let's just look at the square root of negative 8. So separate it just like we've been doing. So I've got the square root of negative 1 times the square root of 8. So 8 is 4 and 2. 2 is prime, 4 is not. So I'm going to cross out the 4, which gives me 2 and 2s. Notice that I have 3 2s, but a pair is only 2 of them. So I'm going to have my 2I. Now from here, let's go back to the part we left alone. Drop it back down as part of the answer. So I've got 8 plus 2I root 2. Now, anytime that we have this plus sign involved, that's actually a new vocabulary word. It's called a complex number. It's any time that you mix a real number with an imaginary number. So the real part is the part without the I, and the imaginary part is the part with the I. So again, if you need any additional help, I am here to help you. All you have to do is ask.